No, I locked it. What was my password? God, I can't remember. Guess I'll have to call Apple. Hello? Yes, Apple, yes, customer service. Yes, I locked my phone and I can't remember my password. Would you be able to tell me my password or give me some sort of question I can use to open my phone, sorry? Oh, okay, I see. So I do have a security question. Wait, it's a maths question? Okay, well, you just tell me the question and I'll ask my friends and see if I can work it out. Okay, I'll get back to you in 10 minutes. Thank you for your service. Who should I call? Who's the best at maths in our class? Faisal? No. I know. Lavi and Kayvan. That's who I'll call.
Hi Milo, what's up? I'm at the master right now, just finished class. Yeah, I was heading home. But yeah, just tell me, what's the problem? Math exercise? Okay, I can help. Yes, of course. Just tell me where you are.
Ciao Lavi!
Can just go here? Would you help me and Milo with the math exercise?
Milo, maths? Well, of course, okay, let's happen, let's do it.
Okay, we'll do it.
Okay, but why? Why does it need?
25 minutes? We just have 25 minutes to do it. Okay, I'll get back to you. Bye.
Let's run! Comunque micidiale, cioè Milo si fa sentire solo quando ha bisogno. Io sono
allucinante. A me poi non me ne frega niente, cioè alla fine io non voglio fare matematica adesso.
Ma poi Milo chi si crede di essere?
Ma non lo so, ogni volta fa così. Oh wait, I just got a message from him. Voice message. Let's hear it.
Thanks so much for helping me. So this is the question. E to the power of x, open bracket, y plus 2, close bracket. They're asking me to find all local extrema. This means I have to find both the minimum and the maximum points and any saddle points in between. Please help me, because I didn't study as much for the exam as you guys, so please help me out, guys. And not to put pressure on you, but from here counting, you have 25 minutes. Thanks.
25 minutes?
Is he mad? So we have to start directly.
Okay, right now.
Okay, Lavi, so this exercise is an example of multivariable optimization. I remember that we saw this in worksheet 5. Do you remember?
Yeah, I remember that the first step was the first order condition, right?
Exactly.
What was that?
It was the derivative of x and the derivative of y in terms of x and in terms of y.
And then you have to equal them to 0, is that right?
Exactly, then you put them equal to 0.
Okay.
Let's start.
So the first step is to do the first partial derivative in terms of x. So first of all, we have to multiply x times 1, so that will be and then e to the power of x in brackets y plus 2. The second step is the first partial derivative, but in terms of y. So that would be x times e to the power of x, and in brackets again y plus 2. But now, what do?
Okay, now we equal them to 0 and we solve the linear equation. Okay, we have put the partial derivatives equal to 0 and now we have to solve them in order to find x and y. In this particular case, we see that we have e over x times y plus 2 in both of the equations. So what we can do is divide them both by this in order to find x equal to 0 and y plus 2 equal to 0. So we have x equals to 0 and y equals to minus 2. So the point that we find is 0 and minus 2.
But what does this mean? It's just a point, a coordinate, but Milo asked us to find the maximum, minimums and saddle points if there are any. So what should we do now?
This means that we have to find the second order condition now. Thank you, Lavi, for providing us with these rules, because we will need them later on in order to understand if our critical point is a minimum, a maximum or a saddle point. I will show you now how to do it.
Now that we have the critical point 0, minus 2, we have to determine whether it's a minimum, a maximum or a saddle point. So, Kevin, can you help me with the second order condition, finding the second partial derivative in terms of x of f of x, the second partial derivative in terms of y of f of x, and then the second partial derivative in terms of y of f of y.
We have to recall that f of x is equal to y plus 2 e of x times y plus 2, and that f of y equals to x times e over x times y plus 2. Now we need to find the second order conditions. So we have a, b and c. A is f of xx, so we have to take the x out of the f of x. This would be y plus 2 over 2 times e over x y plus 2. Then we have b, which is f of x y, so we have to find out the y out of the f of x. This is equals to xy plus 2x plus 1. Again, times e over x y plus 2. The last one is f of y, which is the y out of the f of y. This is equals to x squared times e over x y plus 2. Now that we have a, b and c, we need to plug in the critical point, which was 0, minus 2, into our functions. So f of xx is 0, f of xy is equals to 1, and f of yy is equal to 0.
From the previous rules, we know that when a times c minus b squared equals a number that is less than 0, so in this case minus 1, we have a saddle point. So now we know that our coordinates 0 and minus 2 refers to a saddle point in the graph.
Perfect, we have made it! We exactly have 4 minutes and 30 seconds left. High five, Lavi! We have a saddle point of 0,
So yeah, today I locked my phone and they gave me this strange question, which was a math problem. And my first initial thought, obviously, was to phone you because you're the best at math. But I thought, no, you're not actually. Kayvan and Lavi are probably better. So I phoned them. You know what? I mean, I don't know what you think about that, but I phoned them.
Dude, you should have just phoned me. I mean, I'm sure I would have solved it much faster than they have. I mean, I'm the best at this.
Well, I guess it's done now, bro. So I'll just phone Apple here and just tell them my answer. And this an emergency call, obviously. Hello, Apple? Oh, yes. So I solved the question you asked. What? What? Do you hear this, Faisal?
Hello?
What? They're serious? No, that's not right. You told me to solve this question. This cannot be a joke. It was all just a joke, and that my phone was unlocked the whole time?
What did it say?
That it was a joke, bro.
Holy shit.
So man, how was work today?
Dude, you know, same stuff. You know, this job, whatever.
Yeah man, I know. Dude, I had the funniest story today. The one dude, the student from IE, I think, called me. He said his phone was locked and he couldn't open it. And he was like, yeah, if there's some security question or something. And he sounded so like unsure about it that I was like, yeah, I'm gonna play a joke and tell him that a math equation is his security question. And he completely bought it.
A math equation.
Yes, I told him like a really hard one. I just googled like hard math equations and I gave it to him.